The sun shines so constantly that it's easy to forget how strange it is. It looks like a gigantic ball of fire in the sky, yet it never flickers, never weakens, and never seems to burn out the way any normal flame eventually does. So what keeps it going? First, the sun isn't burning the way wood or gasoline burns on Earth. Chemical fire needs oxygen, but space has almost none. If the sun were just a giant fireball, it would have gone dark millions of years ago. Something completely different is powering it from the inside. At the sun's core, conditions are extreme beyond imagination. Temperatures soar to 15 million degrees Celsius, and the pressure is more than 250 billion times the air pressure you feel at sea level. Under these conditions, atoms behave differently. Hydrogen atoms are squeezed so tightly together that they fuse into helium, a process known as nuclear fusion. This reaction releases an incredible amount of energy, far more than any chemical fire could ever produce. Fusion is the same reaction behind hydrogen bombs, but in the sun, it happens in a controlled, continuous way. Every second, the sun converts about 600 million tons of hydrogen into helium. A small portion of that mass turns directly into energy, following Einstein's famous equation, E equals mc squared. That tiny loss of mass is what powers the sunlight we see every day. After being created in the core, the energy doesn't escape immediately. In fact, a single photon may take thousands to millions of years to make its slow, random walk from the core to the surface. Only then does it race toward Earth in just 8 minutes. The sun won't burn out anytime soon because it started with an enormous supply of hydrogen, enough to keep fusion going for around 10 billion years in total. Right now, it's only about halfway through its life cycle, meaning it still has several billion years of fuel left. Another key reason the sun stays stable is the perfect balance between two opposing forces. Gravity pulls everything inward, trying to collapse the sun, while the energy from fusion pushes outward with equal strength. This balance creates what scientists call hygrostatic equilibrium. As long as that balance holds, the sun remains stable, not shrinking under its own gravity and not blowing itself apart. It simply continues shining steadily. Fusion is also extremely efficient. Even a small amount of hydrogen can release a massive amount of energy. That efficiency is why the sun doesn't need to burn through its fuel quickly. It gets an enormous payoff from every tiny bit of matter it converts. This slow, steady output keeps the sun stable for billions of years. It's a system designed for endurance, not quick bursts of energy. Eventually, the sun's hydrogen in the core will run low. When that happens, billions of years from now, the sun won't suddenly go dark. Instead, it will swell into a red giant, shed its outer layers, and eventually shrink into a dense, glowing white dwarf. Even in its fading stages, the sun will continue shining gently for a long time. Its final light will be the quiet echo of a star that once powered an entire solar system. So the reason the sun doesn't burn out is simple. It's not a flame at all. It's a self-sustaining nuclear fusion reactor with more fuel, more pressure, and more stability than anything we could ever build on Earth. And it will keep shining long after humanity has vanished from the cosmic stage. That's it for today's video. If you enjoyed exploring with me, don't forget to subscribe to Science Lab, where we turn everyday things into scientific discoveries. See you next time.